Hey everybody, this is Dan Prince and Emilien Macchi. We're going to do a demo today of a containerized undercloud and a presentation just to go over the architectural changes and why we're doing this during the Rocky time frame. So hello and welcome. Let's see. Just kind of a high level. If you're not familiar with TripleO, we've got TripleO is one of the deployment projects in OpenStack. We do a lot. We cover a lot of services and we do a lot of CI testing upstream. It's been around for golly several years, probably 5 years, I think. Um, I don't know. I should have looked up the exact date, but we have an architecture where we use OpenStack in an installer, which we call the Undercloud, to create an Overcloud, which is kind of the multi-tenant cloud that you're installing. So, I guess what is an Undercloud? It's an installer. It's got APIs, many of which are directly OpenStack APIs, like Ironic or Heat, and then we've also got we use Zacar to be able to tie in with WebSockets and Glance to manage images. And then we've also got a workflow API built around Mistral that we use for a lot of our sort of workflows. And so, I mean, this is sort of the high level of what an undercloud is. It uses lots of OpenStack, but there's underneath there's actually some other pieces as well, like Ansible and Puppet. And a little bit of history. When TripleO first started, the architecture that we were using for both the Overcloud and the Undercloud was built around this thing called elements. And this is something that if you've ever used Disk Image Builder, you know what the concept of an element is. It basically allows you to build, an image, and then you can deploy that via like a VM, or you can use Ironic to deploy that image on bare metal. And so our architecture, at the beginning of TripleO was we had a thing called a seed VM. And so this was how we bootstrapped the setup. And you could go from a seed VM to a single or a multi-node undercloud. And then that would be what you would use to provision your Overcloud. So it was sort of a three-step process. Um, and the architecture at the time, we weren't using Puppet, and we were using a lot of sort of homebrew things in TripleO. It worked fairly well, but one of the cons was that the seed VM had state, and it was really tricky to update, and sort of difficult to productize. And it was also 3 steps. So you can imagine from a CI pipeline standpoint, you kind of had sort of three steps to jump through there to get to a working Overcloud. So, wind forward a couple of years, and an idea came about where you could actually take the same elements that we were using in the seed VM, and this was something that was called Instack. So you could basically use the same elements from Disk Image Builder, but actually run them on a local machine instead of using them to build an image. And so we started building our Undercloud with that. So this was basically a consolidation of the seed VM and the Undercloud ideas. And so, the nice thing is it got rid of the seed VM. It did take away one of the things, which was the HA Undercloud. I would just mention the HA Undercloud was never really sort of a proper like feature, but it was something that it has come up again. Some people are interested in that aspect of an undercloud, and changing how we install the undercloud did sort of set us back with regards to that. But I think the general feel was that Instack was a major improvement over the previous setup, in that it saved a lot of time. It was very easy to productize, and we were able to add Puppet support to that later, to sort of align it with, better align it with what we were doing with the Overcloud configuration. So, um, you know, all these are good things, but as the Overcloud continued to evolve, we've since started using a lot of Ansible. We've actually sort of moved away from some of the Puppet, and we're now using containers. In the long term, I think there was some divergence in architecture, and that was so initially. I think it was actually a very good step, and then sort of became a different architecture, and so we kind of moved away from where TripleO had started. So I guess just why are we doing this today? And I guess the benefits of re-architecting the undercloud. Just a couple of points here. We've actually we were able to use the existing containerized undercloud architecture to develop a large majority of the services for the Overcloud and Pike. So, many of the teams that engaged to write the services for the Overcloud were actually able to do so on just a single node setup, a single VM type setup for really fast dev testing. So, it just sort of aligned us around the same tools and the same architecture. And by doing that, we were able to expedite the development of Overcloud services. And likewise, there is no support for containers in the existing Instack undercloud. It uses Puppet for its configuration on bare metal. We switched our Overcloud to use containers in Pike, so it kind of makes sense to go ahead and have the undercloud do the same thing. And another point to consider is that we do have composable upgrades in the Overcloud. A lot of those Ansible snippets reside in TripleO heat templates, and by sharing the same architecture across the Overcloud and the Undercloud, we can actually share the playbooks across the two. Now, it is worth pointing out that in some cases, you will have a conditional there where you may not want to run something on an undercloud setup, but you can control that with a parameter. So there's maybe a minor complexity increase by sharing the architecture, but I think the benefits are probably greater than the cost of tweaking a few services here and there. And lastly, just to mention the multi-node aspect, I think because the architecture is built around TripleO heat templates, and we're now using Ansible. I think, while the initial focus isn't multi-node HA underclouds, it does get us back into the game. We could extend the architecture a bit and support that in the future. So that's sort of all the history of where the undercloud came from. I guess just three things about the new containerized undercloud that you probably want to understand from a high level, and we'll go into each of these in slides in a bit. The installer really, the high level of the installer is just going to do three things. There's a command OpenStack undercloud install, and so when that command the first thing that command does is it's going to take the same undercloud.conf that you're used to with Instack, and it's going to convert that into equivalent TripleO heat template environments and heat parameters. And so basically, let's say you enable Mistral, it's going to basically automatically wire in the Mistral environment, and it might set a couple of heat parameters for that Mistral service. And so the goal here is parity with what Instack already supported, Instack undercloud already supported with regards to the undercloud.conf configuration file. Once that's finished, the installer is going to basically create a heat stack and transform that heat stack into Ansible playbooks. And so there's actually a lot of stuff that's happening in that process. But we'll go through the high levels of it. But just at a simple high level, it's taking the heat stack, transforming it into Ansible playbooks, and then once that's done, the heat stack and the process go away. And then the last thing it does is it just executes the playbook locally on the machine. And at that point, it's just like running Ansible. So you get some benefits from that. Okay, so let's go over how the undercloud.conf gets generated. We can look at this in the terminal if people want to later, but I think I have the wrong file there. I think it's Undercloud config. I just realized that. Anyway, the code for that lives in TripleO client v1 Undercloud config, I believe is the file. Emilien, is that correct? Little blip in our yeah. So we'll fix that in the deck. That's linked into the Etherpad. But anyway, the code lives there, and so if you ever wanted to wire in a new service into undercloud.conf, that's where you would want to look, and that controls sort of the parameters and wires everything up. But basically, once it reads that file, it's going to use. I gave an example of the environments down there. It's basically going to use environments like that. So if you've got Ironic, Mistral, and Zakar enabled, you're going to get an environment that creates the heat stack that looks something like that. And then the last part is config download. That's always going to be added because we always want to use config download to convert the heat stack into Ansible. So, I mean, really, that's just sort of a wrapper. It takes the undercloud.conf, converts it into heat environments and heat parameters so that we can run a resulting heat command under the covers of the installer. So this all sort of happens transparent to the end user. The second thing is, so it's going to launch heat. The installer is going to launch heat. And so the way that it does this, it actually does it in a way that won't conflict with heat running on the machine, either on bare metal or in a container. So it's going to do it on an alternate port, and it's going to use a couple of tricks to launch the heat process so that it's it's very self-contained. So one of the things is we added a new heat all binary in Akata, and this is actually in kind of sort of weirdly named heat OpenStack heat monolith package. But what that binary does is it basically gives you a single process launcher that can fork exec heat API and heat engine at the same time, and so by doing that you can actually sort of get a feature that feels like you're sort of using heat as a library, and so we run RPC backend equals fake. We use a fake keystone backend, and we set the database to SQLite. And so, this gives you a sort of a when we run the socket is set to so it only listens on localhost. So all these things are there. We fire up heat all, we throw a stack at it, and then we basically convert that to Ansible using config download. And like we, a couple of slides ago, that environment there, so the config download is very similar to how the Overcloud config download works. So we, the Undercloud installer has really already benefited from some of the work that's ongoing, for the Overcloud. Initially when we started building this Undercloud thing, we were using heat hooks and sort of looping over and using OS collect config. And so config download really made this nicer so that we can actually just run Ansible instead of creating our own loop to run OS collect config, which is a lot more complex. So if you're interested in this code, you can actually see there's a Python module there, TripleO deploy. It used to be called Undercloud deploy, but it was recently moved to TripleO deploy, just to sort of consolidate it as part of the all-in-one installer efforts. And so, the benefits here is this is much better operator feedback. I think, people are used to Ansible for a lot of CI, and we're starting to use more and more of that for upgrades of the Overcloud, and installation of the Overcloud now too. Also gives you the ability, if you want to execute, playbooks manually. The only sort of con is that it's the same thing as the Overcloud, is we do still have an ongoing effort we still require some heat agent hooks. So there is sort of that complexity left, whereas with past instack stuff, you would just be executing Puppet. modules. We still have a few he agent hooks that execute via Ansible, but I think as we whittle away at those, eventually that should be negligible or eliminated entirely. So a couple of impacts here. Operator impact, I think it's not a huge impact to the operator. We still use the same undercloud.conf. Obviously, the operator needs to be aware that we're using containers instead of packages. When you first start the installer, you have some options in the config file to be able to choose where you pull containers from. And so that's part of the installation where, if you want to pull containers from a remote registry or a local registry, you can do that. And we have some TripleO client commands to automate how you can build that registry or the file that, tells where to pull containers from. And as far as actually running the installer goes, I think in general, I like the feedback quite a bit. It's now just running Ansible, and so it's easier to follow and sort of be able to debug and reproduce some of the failures that you might hit, or just development if you're in your dev environment and you're running a local setup. You can get the Ansible feedback quite nicely. And then the last thing for operators, I think, is just that the upgrade process from an existing bare metal upgrade, it should be transparent. We have the upgrade should take you from bare metal to containerized underclouds in place. And I believe the upstream CI job is now testing this. So I guess the next thing is developer impact. I think the main thing here is that the architecture, since the architecture is the same, we're not duplicating work. And if you want to maintain a service, like just for example, like Glance or Keystone, those are also services we have in the undercloud. So you can actually just dev test those in an undercloud type setup. Maybe not with undercloud.conf. There are some advanced interfaces, and we'll get more into that in the next slide. But with anything that's in the undercloud, you actually could test with undercloud.conf and the undercloud commands. So, I think benefits of the architecture alignment are, pretty good there. It kind of gets TripleO back to, I think, where it started as far as reuse across the two. And then building on that, we have containers in our Overcloud now, so we get containers support for our undercloud kind of for free. Maybe not entirely for free. There are obviously some documentation and upgrade impacts for end users that are actually moving to the new architecture, but there weren't any plans that I know of to upgrade in-stack undercloud to use containers, aside from switching the architecture out. So I think this is a good step forward there. Like we mentioned, the ability to develop on a single node, that's pretty nice. And again, just to mention, we actually did sort of dog food this during the early on in the Pike cycle. We were able to develop a lot of the Overcloud services using this as a means to dev test things. And then developer impact. You can use alternate interfaces. So you can use undercloud.conf, or if you want to use some of the more advanced heat commands, OpenStack TripleO install or undercloud deploy are the two that I think that I'm aware of that exist today. You could actually sort of throw your own environments and parameters at those and kind of build your own sort of anything is an undercloud dev environment with this. It's just a good feedback loop in general across the Overcloud and the undercloud architectures. So it's going to allow you to dev test things on a single machine with a lot less time. You don't have to worry about, creating an undercloud and an overcloud. In some cases, you will need to do that still, like if you're testing HA things, but in other cases, if you just need to test a single node service or a config change, you could probably do that, much more quickly. And like 10 or 20 minutes in some cases, whereas, the time today to do a multi-node testing setup is, a lot longer than that for most people and requires more hardware and resources. And so just summing up here, a couple of future impacts. I think this is stuff that doesn't all exist today, but it's worth just sort of mentioning because these could, significantly benefit developers in the future. So, if you want to be able to, test a patch that you don't have a container of, today Cola supports source containers, and so if you've ever built, all of our containers in TripleO currently are built on Cola containers, which is an upstream project in OpenStack, and so most of our packages, or all of our packages, I think, are built using. I'm sorry, all of our containers are built using packages. So if you had a patch, like a custom patch, one way you could, create a container of that patch would be to create a source container and then swap that in. That might work for a lot of cases, and it might not work for some other cases. And so the next thing to mention is, I know this was one of the questions that came up on the Etherpad, was the ability to sort of ninja patch a container that's built with RPMs. And so again, the idea is you have your own sort of Garrett patch. You want to swap that in and test it quickly. This is something we could automate around and make it so that it's really nice. Future, we've got an ongoing effort in Rocky. We have a spec. It's sort of a next generation type installer. It's called the all-in-one installer, and I think the goal there is it nicely aligns what we're doing in the Undercloud and the Overcloud, and sort of cleans up some of the commands that we're running today, and makes them more intuitive, hopefully. And that, I think, benefits developers in a lot of ways. The last few ideas here, I think eventually, this is something where, a lot of people could actually replace DevStack for their dev testing environments with something that's a lot more production. You can actually create a multi-node, HA overcloud with it, but you could actually very quickly dev test something in a manner that you would with DevStack today, and test your own patches out and stuff like that. And then, I think that pretty much sums everything up. Emilien, do you want to take over now?
Yeah, thanks, Dan, for this nice presentation. So right now we're gonna spend a little bit of time doing a share screening on the terminal. Thank you, Dan. So I have a quick demo. So we prepared two VMs. One where we will demonstrate how we can deploy the containerized Undercloud. And because it takes some time to do it, like running the actual deployment, we also prepared a second instance of an Undercloud that is already deployed, so we can play with it and show the results. If there are some QA questions about how it works, we can actually run the commands. Like Dan mentioned, for the operators, there is no much change in the user experience. The first thing that you want to do is to deploy the Python TripleO client. So let's do it. All right, so once we have the client, it's going to take a minute. So once we have the TripleO client installed, as before, we will need to copy the undercloud.conf, prepare the configuration of the undercloud. So that's the same experience as before. You have a single configuration file. You will find most of the parameters that you're already familiar with. They are in the undercloud.conf. We added some new parameters in the Rocky cycles. They are documented, but basically most of them are the ones that you could find in the previous cycle. So let's wait a little bit that the TripleO client will be deployed. It should not be that long.
Emilien, do you want to create a new terminal and go edit the undercloud.conf while we're waiting?
Yeah, can do that.
Okay. There you go. You're in a new.
Okay.
Do you want to? Yeah.
Yeah. So if you go here, so the undercloud.conf is basically the same as before. It's just generated by TripleO client now. So really, you will find a lot of the options that we had before. We had a few ones. For example, there is one that you really want to know is the cleanup. The cleanup option is basically if you want to clean up the Ansible playbooks after the successful deployments. Usually when I'm developing, I set this parameter to false. So if there is anything that fails, I can quickly jump in the playbooks and debug. If it's so the default is true. So the default is actually doing the cleanup. When you do the cleanup, basically you will just have a tarball at the end of the deployment that you can use later if you need to debug. But the cleanup will basically remove the directories that contains the hit templates and the Ansible playbooks. So let's check if I can.
There you go.
Yeah, it should be done in very few. So one thing I didn't mention is there are some options that were included in the Rocky cycle. You definitely want to have a look at them. There are some many options for the containerized the container. Sorry, if you want to tune some parameters, etc. So the default, we are going to use the default today. So no fancy configuration. The only thing I can enable. So this is done. So let's prepare the configuration. All right. So that's the default configuration. I used to disable the cleanup. So in case that fails today, we can check why, etc. And again, if we let the default, it's not a big deal because we still have the tarball at the end that is generated. So yeah, we have a few new options here specific to the containers, and we have a few other ones for the routing networks that we. I think we had all of them in Queens, but basically, yeah, that's the same format. Nothing much new for the operators. So I'm gonna go ahead and run the deployments. Keep in mind that the command at the end of the cycle will be the same as before, but right now, because the containerized undercloud is not by default, we have to use the use -hit. So again, once again, at the end of the cycle, what you're seeing here, the use hit will go away and you will run the same command as before. All right, so what you're seeing now is, so we are generating the heat templates and the environments based on the undercloud.conf. So we, once this is done, so we are creating the environment file, and then we are spawning an ephemeral heat installer container, and we will create a heat stack like Dan mentioned before. So we create a heat stack based on the templates and the environment that we generated from the undercloud.conf. And it takes a few minutes. It's not that long. Once this is done, we execute the config download to generate the Ansible playbooks from the heat stacks. So we download the playbooks and we just execute them locally. So it will pop up in very shortly. There are still a few resources that are still managed by Heat, like the net config, and we still have a few other things that are not done by Ansible, but yeah, let's wait a little bit quick.
One of the things to point out about the heat process here is it's actually running on bare metal. You can run it in a container as well, but by default it runs on bare metal. A couple of things we do to make it a little bit faster is we run the SQLite database, which does a lot of read and writes. We actually run that in a RAM disk. We found out that cut the heat stack creation time down quite a bit. That's stuff that's all in the heat launcher code inside of TripleO client now.
Yeah. So a few seconds left. And
If it
yeah, go ahead.
hello, so if we are keeping it in RAM, then if we reboot and if we want to update Undercloud later, how it will go?
So the heat stack, that's a good question. So the question is, if we're keeping the heat stack in RAM, if you reboot, what happens? So I mean, the heat stack we're creating here is by design ephemeral, which means it's going to go away. We don't necessarily want to keep it. We're only creating the heat stack for the purposes of generating an Ansible playbook. So if you want to recreate it, you would simply just run the installer again, or run an OpenStack Undercloud upgrade. Either one of those commands would give you the capability to recreate another heat stack and download Ansible out of it. So really, the goal here isn't to create a heat stack to manage resources. It's that our current architecture for the Overcloud services is built around heat. And so what we're doing is we've created a mechanism, sort of a library sort of effect that transforms that into Ansible playbooks. Does that?
This is fine.
Okay, one other thing we can discuss quickly while deploying is the upgrades process is actually taking the upgrade tasks that we generate right now for the Undercloud stack. So we actually reuse the same upgrade tasks from the Overcloud. So if you're familiar with how the Overcloud is upgraded, and we actually take the same Ansible tasks from the TripleO heat templates. So that's also one of the benefits from reusing what was in place already. And actually, we implemented those tasks in the Pike cycle, so they have been there for a while now. So that's kind of one of the reasons why we switched over that during the cycle. Using those tasks, I can quickly show you the upgrade process later, but that's exactly the same command as before. That's the OpenStack Undercloud upgrade, and that will do the exact same thing that you see now on the screen, except that we'll execute the upgrade task before the deployment tasks. So that's the only difference. And you can run it like anytime that you want. You can run it every day, and that will just make sure that you have the last containers. So now, as you can see, that the stack was created. It took maybe 5 minutes, something. Right now, we are executing config download, so generating the Ansible playbooks and running the deployment tasks. So the deployment tasks are now running on the screen, as you can see. That will take some time, so I don't think we need to stay on this screen. But basically, what it's going to do is to executing some of the resources that are converted to Ansible tasks. Prepare the container, so we are going to deploy the 5 steps where like we have on the Overcloud. We're gonna deploy the services on the 5 steps and execute some of the post-deployment things that we were doing in Stack. So I don't think we want to stay on the screen. We can jump on the other screen then if you want to do it. So
how's that?
So that's the Undercloud that is just deployed. So if you take a look at the files, so we have the instack Undercloud log. So we can check the logs when it finished. So when it finished, you have a message that tells you that the Undercloud was complete. You have the password file and the stackrc file still available. There is also, as you can see, there is a tarball which is Undercloud install, and you have the date, and that's tarball that you can use if you want to have a look at the templates and the playbooks that were generated when you did the deployments. Because I run the cleanup because I disabled the cleanup, I can have a look at the Undercloud Ansible and the TripleO templates. So that's something also I can show. Right now the files are generated by sudo, so there is a permission thing that we need to fix. But basically, as you can see here, we have the Ansible playbooks generated by config download that really deploy what we need on the Undercloud. Yeah, so we have the stackrc file. And check out the endpoints. So we have the exact same services as before, and we try to maintain a parity with what was done on Stack Undercloud configuration. We also have the containers. As you can see, we run all the services in containers. It's very similar to what you can see on the Overcloud, right? So if you're already familiar with the Overcloud containers, that's something you will easily understand on the Undercloud. Yeah, Dan, is there anything I missed to demo?
No, I think that's good. We can switch over and talk about some questions now.
Yeah, just for the upgrade thing, like I said before, for the upgrade, that's the exact same command. The use heat will go away, right, like I mentioned, but right now it's here. Just one thing, when you run the upgrade, it will ask you, are you sure you want to do the upgrade? Did you perform a backup before, etc.? So that kind of stuff. We added some user experience.
So I think we've got questions going into the Etherpad. I think I already linked that into the chat, but I'll put it in there again in case it didn't show up. So and there's a few answers already as well. So I guess the first question from Tony is, I think he's wanting to understand how containerizing the undercloud affects multi-architecture registry things. And so that would be, I think, the ability to host containers on the undercloud registry that are from multiple architectures. So I actually don't think containerizing the undercloud has any effect on that. It should work the same way that it does with Instack today. Your registry should be able to contain the same things, and you can have different tags for different architectures and so on. So let's see. The next one is Dimitri. Had a question for basically, yeah, how to patch a workflow or how to add your own patch into for developers. So I actually think this is something we briefly mentioned it in the presentation. If you want to add your own patch to a container, say you're working on Ironic and you wanted to be able to test a new Ironic patch, what you could do today is you could just build, your own container for Ironic and then respin or just relaunch that container to test it live. And so that would sort of short circuit the dev testing cycle quite a bit. It looks like what Dimitri's suggesting is effectively a command to automate that. So you can actually just point it to your own, Git patch and do that. And so I think that would be a super useful thing to do as part of a local dev test setup. And we could probably pull that off fairly easily with this architecture. And now that it's containerized, especially, I think it makes it very nice and easy to do that. So next question is, Carlos, how having a containerized undercloud will affect backup restore? Emilien, you were just getting ready to show backup restore. Do you want to take this one?
Yeah. So I think for the MySQL, we use the same directory as before. So varlib MySQL. So I'm just wondering if that's something we need to check for the file system for some directories and files that we pick up. But other than that, that should just work as before, I think. So yeah.
Okay.
There is another question about when the containerized undercloud is meant to be the default. That's a very good question, and actually we are working on this right now, and we identified a few blockers to make it happening right now. But the team is working on it, and the target, the goal is to have that before the end of milestone 3. Of course, we really want to make it the default as soon as possible. So that's something we are working on right now.
So here's a question: how to test customized services? Is there a way to share similar feature scenarios we have in the Overcloud, or do we need to update undercloud.conf? So that's a good question. So I think there's actually a couple different answers here. One, there are multiple interfaces to this. So there's an undercloud deploy command, and so what we did as part of Pike, and I think that command is still marked experimental, and it's probably deprecated as well, because eventually we want to move towards an all-in-one installer interface. But just worth pointing this out because we actually used just that to develop most of the Overcloud services in Pike. And so, for example, services that are part of the Overcloud, like some of the Neutron services that aren't typically part of the undercloud could be developed like this. And so what we would do is we would actually, with the undercloud deploy command, we would actually use the -- templates option to, here, let me just give you a quick example. Where are the heat templates in this environment, Emilien? Is it? Yeah, this is it. So what you can do is you can actually check out your own heat templates, and then edit the roles. Let's see, roles, data, Undercloud, and you can actually just prune this list. So if you direct the installer to use this, you could actually just prune this list down really quickly to be just what you want. And so you could just delete all the services you don't want and add in here what you want. And so it could be MySQL, or whether or not this is correct. If you were just doing AODH development, you could basically just have MySQL Keystone. You probably want Keystone in there as well. And you could create, whittle it down and create a really tight service set to be able to iterate on just, a smaller set of services. And so I think that's actually, again, the idea for the all-in-one installers, that we're building an interface that somebody's got the command there, OpenStack TripleO deploy my service YAML, and you can basically iterate on your own sort of set of services in a really quick fashion, and basically use your own local heat templates to do that. See, Cedric has two questions. Integration with satellite in order to get a proper container versioning is still possible. See the registry build command that might be issued. Right. I don't remember the one for the Overcloud. So I think the answer here is that satellite has its own registry, and I think you should be able to consume that by passing the right parameters to OpenStack Overcloud image prepare. Do you have anything to add on that, Emilien, or does that sound?
No, I have nothing right now on this thing. No, we haven't changed this thing for Sentinel.
So the next question here is, might the undercloud be split into multiple small under hardware nodes? So I think this is just a general sort of undercloud, a multi-node undercloud, or an HA undercloud question. And the answer is not yet. We still need to rewire some of the networking parameters to make it dovetail into the Ansible that the undercloud uses for deployment. But we, by using the new architecture, I think we're closer to being able to engage this sort of idea again. And I think it's something that's probably going to happen in the all-in-one installer, as opposed to retrofitting that into the undercloud.conf. Let's see. Peacock has a question. Can this effort have anything to do with reducing hardware requirements such as RAM on the undercloud host, or is that totally irrelevant? Yeah, I think the short answer is, as far as the services in undercloud.conf, it's probably not going to decrease. However, that said, when you make the undercloud, more composable, like if you use the alternate interface, for the all-in-one installer, you could actually, whittle the services down and sort of dev test a smaller set of services. Kind of an undercloud light sort of concept that I know Bogdan has prototyped a bit. So yeah, I mean, sort of a yes and no, I think there. Okay, the next question is, creating a stack creates a new VM or just uses the same host where the command is run? Yeah, it doesn't create a new virtual machine. It just creates that stack in the ephemeral heat process, and then once it goes away, it's cleaned up. So it doesn't actually create a new VM for that. It's just done locally. And like I said earlier, the actual installer can run that heat ephemeral process in a container if you tell it to, or it could just run. It could run it as a bare metal process. So, okay, I think that's all the questions, unless anybody wants to ask anything else. And you can always ask on the mailing list too if you have any other questions. We can follow up and ask or answer things there. Anything else you want to say, Emilien, or is this?
No, I've tried to reply to the questions in live, and yes, we had very good questions. Yeah, thanks everyone for participating. I hope the presentation was enough deep. But if you have more deep questions about what we worked on, and if you need to know more about specific things, feel free to provide this feedback, and we can make it again. Yeah. I hope the demo was useful as well. Feel free to keep us posted on the mailing list, provide any feedback or ask questions. It's very helpful for us as well. So yeah, don't hesitate, please.
Yep. Thanks, everyone. See you guys online.
Thank you.